Hey guys, and welcome to a new video. Today I want to show you a very practical Android security testing setup. The topic is simple: how to make Android trust your proxy certificate not just as a user certificate, but as a system level certificate. This matters when you want to expect HTTPS traffic from Android apps using tools like Charles Proxy, Burp Suite, Meeting Proxy, or anything similar. This is only for your own devices, emulators, lab apps, test environments, or systems where you have permission, not for random apps or other people traffic. Why do we even need this? Well, Android has two certificate stores. One is the user certificate store and the other is the system certificate store. When you install certificate through Android settings, it's usually going into the user store. That can be enough for browsers and some simple cases. But many Android apps do not trust user install certificates. Some apps only trust system certificates. Some apps also have their own network security configuration. And some apps use SSL pinning, which is a separate problem. And we actually talked about this already in the previous videos. So if you want a cleaner mobile testing lab, especially for HTTPS interception, you often need your proxy certificate to be installed as a system certificate. For this demo, you need a rooted Android emulator or rooted Android device, ADB on your computer, and a proxy certificate exported from Charles, Burp, Meeting Proxy, or other proxy tool. The certificate can be in SER, CRT, or PAM format. The first step is making sure the certificate is the correct PAM format. If your certificate is already PAM, you can skip this conversion step. If it's not, you need to convert it first and then check that Android can work with it. The important part is that Android system certificates actually need a specific file name. You do not just copy the file with any random name. Android expects the file name to be based on the old OpenSSH subject hash. So the flow is basically this. You take the certificate, you calculate the hash, and then you rename certificate using that hash with the .0 at the end. After that, you need to start your own emulator with the writable system partition. This part is important. If the emulator is not started with writable system support, ADB remount will usually fail. Then restart your ADB as root, remount the system partition, and push certificate to that device. Open the ADB shell, switch to root, and copy the certificate into Android system certificate folder. The folder is typically system etc security ca certs. After copying the certificate there, you need to set the correct permissions. The certificate should be readable by the system and it should belong to root. Then you reboot the device. After reboot, you can verify the results from Android settings. Open security, then encryption and credentials, then trusted credentials, then system. You can also verify from ADB by listing certificates inside the system certificate directory and checking that your hash named file is there. The certificate is only one half of the setup. You still need to configure Android to use your proxy. So you should find the proper port and set it. Then you open a browser first and check if HTTPS traffic appears decrypted in your proxy tool. Do not start with the complicated app immediately. First, test with the browser. If browser traffic works, then the proxy and certificate setup are probably fine. If the browser works but your target app still does not decrypt traffic, then the problem is probably inside the app. Most likely SSL pinning, a custom trust manager, native networking, or a strict network security config. This is where the FRIDA, objection, or a custom SSL pinning bypass script may be useful. There is one important Android version note here. On Android 14 and 15, the certificate handling becomes more annoying. Modern Android versions may actually use specific certificate store, not only the old system certificate directory. That makes direct certificate injection less simple. So for training labs, YouTube demos, and course material, I usually recommend Android 11, 12, or 13. If ADB remount fails, the usual reasons are simple. The emulator was not started with writable system support. The device might be not rooted or bootloader is locked. You can also be using the production phone image. Android might block direct system modification. For the labs, just use a rooted emulator image. The final checklist is simple. The certificate should appear under System Trusted Certificates, Android proxy settings should point to your proxy tool, and the browser request should actually appear decrypted in Charles, Burp, or Meeting Proxy. And only after that, test a real Android app. If browser works but your app does not, do not blame the proxy immediately. At that point, the app is probably doing something stricter. And this is where the real mobile security testing starts. Thank you guys for watching, please subscribe, please press the like button, and see you soon. Bye guys!